Okay, so I'm saying that I've started recording, so please be cordial with your conversation. This is going to be on YouTube. So when I save it, it's
Okay,
safe
sir.
for good. Okay,
Okay, sir.
so
Okay, sir.
now, so first of all, I'm going to look at questions that we started looking at in algorithm. Okay, the questions we solved in the algorithm. If you have watched the video, then this should be a straightforward um, session for you. But if you haven't watched the video, I recommend go and watch. Most of the questions that are coming up are basically with respect to the video that have been watched. Somebody has asked I should go over how to create a loop. When I get there, I'll look at it. Okay, so I'm going to share the PowerPoint and we'll go straight to the questions and then we will take it from there. Okay, so this was a question I solved in my recording. Remember, this topic algorithm is basically a programming language topic, but we are looking at it because in mathematics, you have to learn the procedure or what you have to follow to be able to solve a problem, which algorithm is virtually all about. So some of your questions or some of the things that we will come across, the syntaxes, which are a bit technical, you will find out as you'll be taught programming languages by the other lecturers. They will take you through these. And some of the questions that have come up in my previous lectures, people were asking whether the syntaxes being used in this particular pseudocode is the same in all other programs. They are not the same. But I have to use these syntaxes to explain what we've been doing or what we are trying to do. Now, so basically, this problem is what we call the salesman's algorithm. If you Google, you find out that either the salesman algorithm or the traveler's algorithm is what we are trying to understand using this problem. And it will give us the foundation or the fundamentals to be able to understand other respective algorithms. There are so many types of algorithms, so I recommend take your time and go through these questions, these videos, and make sure you understand them. I've seen a question, please, how can you describe algorithm outputs? Okay, remind me if I don't answer that. So please, can we join two or more different algorithms like joining compound statement with assignment statement? Yes, you can do that. Normally, when you start writing algorithm, you start with basics. Maybe you need, if you're designing, let's say a website that will embed a date or will embed people voting. You see that interface to write that algorithm will be fusing other type of algorithm in there. You may have an algorithm in, let's say Java, and then you will introduce a PHP or HTML algorithm to fuse it. So yes, we can write algorithm joining one thing to the other, but again, well, like I'm saying, leave these questions for your programming language lectures when you are dealing with those topics. Okay, so this was a question. There were 6 towns. We want to see how best we can visit all the 6 towns. The fundamental problem here is what is the shortest distance to follow to visit these 6 towns? And so if you watch my video, you realize that I use an Excel page to be able to explain what I was doing. And I'm saying it just, it makes my work easy. That's why I use Excel. Okay, so this was the problem was on the right. I'm sharing the screen now. And all we wanted to do is, where do we start? Where do we go from where we started? So in my video, I did, I started from Accra and I did another one starting from Edina. Now, today I want to take another one. If you haven't gone through, let's just pick another one and then go through it, and so that we can see how this is done. So I'm going to pick, let's say, Cape Coast. Let's say I'm starting from Cape Coast. Okay, so all you need to do is go back to the data, which is on the left, and then find out look at the capos row. This is the capos row. It's made up of 142, 42, 108, 168, and 61. Now, so if I'm starting from Cape Coast, what is the shortest distance away from Cape Coast? What town is that? Please, if you know, unmute yourself and answer me.
Edina.
Edina. Thank you. So
Yes.
I go to Edina, and the distance is 42 kilometers. Okay.
Say Edina.
Thank you. Please try and mute
Yeah,
yourself.
I'll mind you.
Thank you. Thank you. Okay, now we are back in Edina. Now we go back and look at the distance from Edina. Edina is the second row. What is the shortest distance away from Edina?
Yendi.
Yendi.
Yendi. Okay.
Yendi say, Shamesha.
Well, some people are enjoying at the background. Well, Yendi. Okay, so Yendi is 45 kilometers away. So we connect from Edina, we go to Yendi, 45. Now we are in Yendi. Now I think I will continue. The shortest distance away from Yendi is 45, which is Edina. We've been there already. So there's no need to go back to Edina. The next smallest value is Cape Coast, which is 61. And we've been to Cape Coast. That's where we started from. Okay. So the next smallest one will be Accra, which is what? 81. Okay. Accra is 81. Okay. Now we are in Accra. Accra, the shortest distance away from Accra is 81. We've been there, Yendi. The next Takrady. Thank you. So I have no option than go to Takrady here. Okay, Takrady is 107. And then from Takrady, if we look at Takrady, the shortest distance is what? 66, which is Koforidua. So now, thank you. Now, we now have all the total. Thank you. Now we have 341. Okay, it's just like starting from Koforidua. Now, so I recommend finish the rest of the table, and based on the one that will give you the smallest distance, you can be able to tell. Okay, somebody saying it's Cape Coast rather. Is somebody having another opinion? I think what we've done is the best option for what we have. Cape Coast, Edina, Yendi, Accra, Takrady. Now, so then in back to my PowerPoint, I said that the approach to be able to solve this is to use what we call the graph theory. Okay, and I explained in my video that when you say graph, we don't necessarily mean X and Y axis. We mean beyond X and Y axis. Yes, we can use graph theory, but we mean beyond X and Y axis. Somebody's asking, please, the shortest distance from Edina is Cape Coast. Is that it? Yes, shorter distance away from Edina is Cape Coast, but we've been there already, isn't it? That's why we went to Yendi. Okay, please keep your questions coming. Now, so I'm saying that we will use what we call graph. So if this is the first time you are saying graph in Discrete, when we say graph, we mean anything that can be connected by a corner and by a line, or anything that can be connected by what we call vertices and edges. Okay, so we're going to employ the use of a graph to be able to show how this problem can be solved. Now, so our ability to connect all these 6 towns will give what we call the minimum total weight, which we will now refer to as an algorithm. Therefore, the definition of an algorithm is any finite, listen to the keyword, finite, sequence, precise. These are the words, finite, sequential, precise instructions to do something. Okay, so now we want to now explain what a graph is. Now in your Socrative, I ask questions on graph. So I'm going back to look at what a graph is, and then we'll explain more and by looking at graph. No, so here I've explained that a graph is simply anything that can be connected by vertices and edges. Okay, so yesterday I took my time, yes, and I gave these examples. For example, if I take a rectangle is made up of 4 vertices and 4 edges. So a rectangle formula will be 4,4. Now, when you take a triangle is made up of 3 corners and 3 lines. So we have a triangle made up of 3 vertices and 3 edges. Now, what about a hexagon? What would be the formula for a hexagon? How many vertices and edges does a hexagon have?
7,
7.
6 and 6.
6,6. Hexagon is 6.
6,6.
Okay, thank you. Now, I'm now going to give you different graphs formulas. Then you will tell me how to draw them. So we are here. Now, if I give you a graph 4,3, how do you draw it? Any help? 7,7, 6,6. Okay, thank you. How do you draw a graph with 4 corners but 3 lines? Now I have four corners here, A, B, C, and D. So show me how I can join them. Somebody say he can't hear me. Check your mic, please. A to what? Somebody say A to what? A to what? A to B. Okay, so this A to B. Okay, then the second line, where will you want to join it to?
A to C.
A to C. Okay, so I have A mapping to C. Now what will be your third line?
C to D.
Again? B to D.
C to B.
C to B. Okay.
Yeah.
C to D.
Now C to B. Okay, that is 1. So this is 4,3. Okay. Now we can do the same thing. We can do the same thing. We can do the same thing, but this time I can pick something like A mapping to D. Yeah. I can pick C also mapping. Somebody is drawing, oh, please, on your screen. C mapping to B, and I can pick, let's say, C mapping to B like this. So please, the graph, basically the formula will determine what we do. Those who are writing on their screen, please, we are recording those so people can make sense of what I'm doing. Now, how do you find 4,0? How do you find a graph called 4,0? How do you draw that?
Sir,
Yes.
question.
Yes, I'm listening.
Sir, please, the first example, we did A to B.
Yes.
And you said a vertex refers to 4 corners, and
Yes.
the edges are lines.
Yes.
And when I counted I got the 3 lines as the edges, but the vertices, the corners, they were 3.
No, there are 4. 1, that's what I call the A, B, C, D. I hope you can see A, B, C, D.
Yes, sir.
Okay. I'm making them red for you to see.
Yes,
so
sir.
the corners are the red, okay, but the lines are simply the black ones. So you would decide based on the formula, you would decide which corner to join to which corner. And I'm trying to explain that 4,3 can be represented as this one, or can be represented as what I've done here, or any other shape that can have 3 lines and 4 corners. Okay, any other question? I'm looking at the chat.
Hello, question.
Yes, please, I'm listening.
Please, so is the first number always the vertex and the second number is always the edges?
Yes, that's what the formula says here from the definition. A graph is defined by vertices and edge. So when we are defining it, this is how we define a graph. The first number is the vertex. The second number is the edge. So that's how we write it.
Okay.
Okay, now I want to pick one more example. How do you draw a graph 1,5? Any help? 1,5. Yes, A, Mondia, A. 1,5. Anybody who can help? Okay, let's see. If this is my graph A, let me place A here. I'm saying that I want to draw 5 lines from this. How do I do that? Any help?
Yes, sir.
Yes. Uh,
Hello.
yeah, yes. Please, if you want to ask a question, you mute yourself. And somebody is asking, does it have to form an enclosed shape? It can look like any caricature so far as it satisfies my formula. Okay. People keep on dropping their lines. Next time I have to share my host so I don't have to do this. Yes, it doesn't have to be an enclosed place. It just must make sure this particular figure has one corner but 5 lines. So you must be imaginative in doing that. People are drawing, and why don't you tell me? Okay, yes, I'm listening.
Hello, sir.
Yes, I'm listening.
Hello.
Yes,
Yeah, I think
these are my 5 lines. What do I do to them?
you can draw 5 lines. You can draw 5 lines meeting at the point E.
Thank you. So I can do something like this, something
Hello.
like that. Yes, I'm listening. Something that looks like this.
You can draw 5 lines meeting at the point E.
Exactly. So that is what I'm trying to do now. I have 4, then I can do this. Oh, who is this? Okay, somebody is trying to draw for us. Please, we have it. Kindly clear your screen. So anything you can draw, it doesn't need to be really enclosed, but virtually all the lines are connected to the vertex you are talking about. Okay, so the formula will determine how your shape looks like. And I'm saying you don't have to make it look fancy so far as, and even though I'm drawing straight lines, if I have time, I'll be drawing curved lines. It doesn't matter. Okay, it doesn't really matter that the lines are straight. Yes, any question?
Hello, sir.
Yes, I'm listening.
Hello.
You can ask your question.
4,0.
No, I said 5,0.
Yeah.
Hey, sorry, 1,5. I'm doing this. This is what I'm doing. I am doing this, 1,5. That's what we've solved here. Now, if you want 4,0, if you want 4,0, this is 4,0. This 4,0. Then you have 4 isolated vertices like 1, 2, 3, then 4. So this is 4,0. It's not connected by any line. Or can simply scatter them around any way you want. So first is 4,0. This is 4,0. So 4 vertices, no line or no edge. We call them isolated vertices. All of them are not, or we call them standalone. If this is a PC, we call it standalone. They don't communicate. Okay. Normally, when you have a server, you want it to stand alone and not communicate, or people have access. This is what you do. Okay. I hope I've answered you. Okay, now let's go on. So back to the question. We solved using Accra. So in Accra, from Accra, we went to Yendi, and that was the line I have here. Accra to Yendi. From Yendi, from the table, we went to Edina. That is, I'm looking at these values I have here. So Accra to Yendi, Yendi to Edina. Now, Edina, we came to Cape Coast. So Edina, we came to Cape Coast down here. And then from Cape Coast, we went to Koforidua, and Koforidua went to Takrady. Now, so the employing of this technique will help us to be able to get different types of graph. I've just done 2 of them. But if the problem happens to have more than 6 towns, let's say I have 180 towns, then I need to use an algorithm that will go through all these 180 towns. It means that 180 set of 6 vertices and connect all of them and find out which one will give me now my minimum value. Please, this is how we schedule airlines. This is how we maximize the use of these errand guys using motorbikes and all that. In the West, this is how they do their train system and make sure that you maximize the time. If the train has to leave at 6, whether there are 4 passengers or there are 20 passengers, it will move. So that is how we schedule and make sure that at the time you want, you can be able to move. Remember, the criteria for this problem is shortest distance. In Ghana, the trotro, they do buy maximum money when they are loading. They don't use shortest distance, they use maximum money. So till I have all my passengers, I don't move. That type of problem, we can't solve it using this because we are interested in making sure the trotro, that's why we call it trotro, or we call it, yes, Trotsky. Okay. So,
I read.
yeah, so make sure that I have the money. So they don't care how long they spend at a bus stop. They just want to make sure they can make the sales at the end. Now, if we maximize, if the person does have more than one vehicle and he is able to make sure he wants to make money, then he knows the rush hour, he knows the time. There was a particular year group, I gave them a question. If you have a trotro, you're a businessman, you have a trotro and you have a taxi, which one will you use in the morning? Which one will you use in the afternoon? Which one will you use in the evening? And think about it. That will help you to schedule this problem very well. So these are applications to what we've just looked at. And I said, the reason why we are employing the use of this is because it helps us to be able to maximize and find a minimum time. And somebody said, please, no one should write on this. Okay, please, try and clear your screen so we can see. Secondly, sir, please, so you have to draw the line for all the trips. This is for just exercise sake, okay? We are just trying to explain how this problem is done. And I'm saying, if the problem happens to have 180 cities, you can't draw graphs for 180 cities. That is why this formula, which I shared in my PowerPoint, should be used. Back to my PowerPoint. The formula to do this is what we call selected vectors. So I'm using these steps. The algorithm are precise instructions. So the instructions to solve this is after you've drawn your 6-sided or 6 corners, you virtually have to select the vectors, any of them. The next step is connected to the nearest neighbor. Okay, that has not been connected. And then the last step is repeat step 2. So if we are doing this for 180 different, it means that I will select the vectors and repeat this problem for 100 and maybe 6 times till I've connected all the vertices. Okay, so you guys, I have just about 10 minutes and then we have to restart this whole thing again. So let me try and get to the syntaxes. So this is the algorithm, or these are the steps to follow to solve this problem. So the answer to your question, you don't have to draw all this in an exam. I don't even ask these things in exam. I'm trying to explain what algorithm is. I'm just trying to make you see that when you have a problem, we can have steps that can help us solve the problem. Basically, that is what we are trying to do here. And somebody said, please, how can you describe algorithm output? I'll get there. Can we use Kruskal's method? You see, people are reading. I like this guy. Yes, you can use Kruskal method. We call this the shortest distance in connecting to 2 points or connecting to a number of points. And when I used to teach Coventry, this is something I teach them, I think the 3rd or 4th week. Yes, you can. If you know how to use it, you can do that. Okay, so thank you very much. Now, let's now go and look at these syntaxes. Nobody has asked me anything about assignment statement. I assume you understand it. So this is a control statement. The question was how to find loops. So when you are dealing with loops, this is when you use what we call the conditional statement. Okay. Now, I'm sorry. Somebody want to ask a question? Okay, I'm saying when you want to deal with loops, then you use what we call iterative, not conditional. Condition is when you are dealing with an output that has more than one result. We use what we call an iterative statement. Please, there are a lot of them, but in my slide, I only brought 2. What we call the for to do loop, and then while do the following, then repeat till you have finished the condition. These are the 2 examples I have in my slide. A question. Please explain all the types of algorithm. All the types, that is like go and watch the video. I think Harrison will support me on that. Please watch the video. If you watch the video, if there is a problem in one of them, then we discuss all of them. We only have about 40 to 1 hour for a live session. So please watch the video, and then if you have a question on specific ones, then I explain. Okay, so I'm going back to my Excel. And I'm going to take the two examples I've been doing for every class, and I'll explain the iterative statement here. Please explain compound statement. Hey, you want me to explain everything? Okay, let's take a problem, and then please remind me if I have to go over this compound statement. Now, so in my Excel, I explain what assignment statement is. Assignment statement is something that we use to assign expressions to variable. Okay, assign expressions to variable. Okay. Please, somebody's playing music in the background. If you're enjoying your room, let's listen, please. Now, I'm going to try and pick an example here and try and explain what assignment statement is.
Sir,
Yes, I'm listening.
what should you go and watch the video?
Hey, when did you join my class? Okay, the video, please contact the class. Quiet. Please contact Harrison. He has links to all my videos. And if you can go to Model, all the videos are there. Okay, can 3 people give me their names? I want to explain assignment statement. I have about 5 minutes to go.
Sector.
So SEC. How do you spell?
Virginia.
SETUR.
Wow, like this. Okay, Eugenia.
Yes.
How do you spell Eugenia? ENIA. Is that it?
Amakwa can spell it for us.
Okay, that's KENETH. Okay, good. Now I'm going to take the initials S. Okay, I'm taking these initials and I'm going to use them for what I'm about to do. Okay, so sector is S. Eugenia is E. Again, and Kenneth, I'm going to use K. Now, the problem is I want at the end of this algorithm, sector will be known as Eugenia. And Eugenia should be known as Kenneth. And at the end, Kenneth should be known as sector. This is what I want to do. This is a problem. Okay? Now, how do I go about this? Assignment statement says that whatever I'm going to do, whatever I want to be assigned, let what I want to be assigned should be on the right. The expression should be on the right. And the name I want it to assign to should be on the left. So on the left, we call it a variable. On the right, we call it expression. People are typing questions. What are your questions? Sir, please, with us, can we also string words? Hey, that is, please, this one, you are bringing my Socrative here. When I finish, I think you should be able to answer the Socrative word. Please say, I can't hear what you are saying. People are hearing me, so check your mic. It must be from your end, okay? Okay, so please just watch what I'm going to do. I want sector to be given to Eugenia. Now, so the first thing I need to do, if I give sector to Eugenia, Eugenia is going to lose his name or her name. So what I'm going to do is that when I begin this algorithm, the next step is to assign Eugenia to a temporal expression, okay? So let Eugenia E be assigned to a temporal storage. And all along, I've been using store to explain, I call it store 1. Now, please, you can call it anything you will remember, okay? I'm calling it store because I'm saying I'm storing the name Eugenia. And the second step says that give Eugenia to Kenneth. It means when I assign Eugenia to Kenneth, Kenneth will lose his name as well. So again, I need to store Kenneth inside temporal storage. So I'm going to call this STORE store 2. Okay. Now that I have stored both Eugenia and Kenneth, now I can do the first line of my problem. Now pick a sector and give it to Eugenia. So which one should be on the right? Which one should be on the left? This one I need an answer. I want to see whether you are following. Which one should be on the right? Which one should be on the left?
So it will be
which one will be an expression and which one will be the variable? Give sector to Eugenia. So which one will be an expression? Which one will be the variable?
That will be the expression.
Set will be the expression.
Okay, so we are
Then
going to
Eugenia
have.
will be the variable.
Thank you. Eugenia will be the variable. So we are going to do this.
Yes,
The
sir.
sector will going to be like this. Now my time is almost spent, so I'll finish this thing up and I'll end and we'll repeat this again. So the next step is we are now going to give Eugenia to Kenneth. Now Eugenia has been stored where? We've installed Eugenia in store 1. So when I write Kenneth like this, I'm going to ask store 1. To give its value to Kenneth. That is what I'm doing here. Okay? Give Eugenia to Kenneth. But Eugenia right now is in store 1. So take the expression in store 1 and come and give it to Kenneth. Now the last step now says that give Kenneth to sector. Now where is Kenneth? Kenneth is in store 2. So sector will be equal to or be assigned store 2. Now by this we have finished our algorithm. Now if you still don't understand, I'll just go over this when we come back. Somebody say, hey, I have 1 minute. So give me this time. Let me end this session. I'll repeat this thing before we do any other thing. So I'm ending for now. The recording will end abruptly. I'm ending for now. Then please rejoin again.
For more information and also to reach us, please contact the numbers on the screen. You can also reach us through our social media handles displayed on the screen. Please do like, follow, and subscribe to our social media handles. A Softek IT Consult. Innovative solutions with the difference.